Hello everyone, we are Senior Design Team 4 and our project was Carrier's HDF5 visualization. Before we begin, let's have our team introduce ourselves. My name is Jeremy.
I'm Noah.
My name is Keshav.
I'm Reed.
I'm Niels.
Our project is for Carrier, who utilize a model-based design program called Dakota to generate a file format called HDF5. I'm going to let Reed explain more on this.
To better understand the need for our project, it's important to understand what an HDF5 file is. An HDF5 file is structured like a hierarchy of folders, each containing metadata and different datasets. The benefit of HDF5 is that it can store additional, beneficial information such as optimal point values, gradients, etc. that Dakota can generate and store for the user. However, this comes at the cost of creating a complex, unintuitive file structure. As you can see, the structure starts off rather simple on the left, but on the right you can see just how complex it gets. What you can see here isn't even 1/4 of the total information. This presents our problem statement. There does not exist any tools which can automatically process an HDF5 file, leaving the tedious work of parsing through the file to the user. And this brings us to our solution, Kaleidoscope. Kaleidoscope is a data visualization application which automatically parses a Dakota HDF5 file and gives the user a simple interface to plot and analyze their files. Now to show you our application in action, I'm going to let Neil start the demo.
Let's begin with our start screen. Before we can begin, we first need to select the desired HDF5. In this example, I'm going to select the Mesh Adaptive Search, an optimization method offered by Dakota. Once a file has been selected, you are brought to the Kaleidoscope dashboard. Here there are now 4 graphs that have been pre-generated for me by our backend processor, which detects the type of data and produces potentially useful graphs. To get started, I'm going to click the Show Options menu icon in the top left corner. This opens a toolbar of many options to control my workspace. To begin with, let's look at the Page Options drop-down box. Here I can select the View Data Table option to get a formatted data set of my results. I have all my variables and several pages of information storing all my entries. I can also apply different filters to each of the columns. With a better feel for my data, let's get out of the table view and begin to generate some of our own visualizations. I'm going to clear all my graphs like so for a fresh start. From here, I'm going to pass the demo off to Keshav.
To begin adding visualizations to my workspace, I'm going to use the Quick Add feature. Clicking an option automatically generates the corresponding graph without any tedious selection processes. Now I'm going to add in several more visualizations, which we'll talk about a little bit later. By clicking on a graph, it opens a variety of unique control options in the left toolbar. Graph options allow me to either remove the individual graph altogether, or view it in a full screen mode. The Move Graph dropdown allows me to shift the contents of my workspace around to potentially let me better organize it. Since I'm satisfied with the order of my workspace, I'm now going to go to the Graphs per Row dropdown, and this will allow me to retile my workspace in regards to how many graphs are in each row. In this case, I want a more isolated view of my visualization, so I'll select 1 per row. Now, since the scatter plot is set as active, I also have several edit options that are unique to this graph. I can control which information is being plotted on the axes, and I can make a variety of other changes, including using a variable to scale the color, change the color scheme itself, change the opacity of the points, and the size of the markers as well. Clicking on a particular point pulls up a data table similar to before, but this time with only the value that I clicked on. Graphs are also interactive, which means that I can zoom in on sections of the data. So overall, this is a good example of a simple graph, and I'm now going to let Noah talk about some of the more complex visualizations that we make available.
Continuing down this workspace, I can find several other of Kaleidoscope's charts that are not as direct as a simple scatter plot. For example, the Pareto chart is a combination of a bar and line visualization, in which Kaleidoscope analyzes and generates the plotted information itself. The multi-line is a simple line graph, but it allows the user to add and delete as many traces to it as desired. The 3D scatter plot adds an extra dimension to the 2D scatter and allows the user to rotate the visualization to fully view the information. These are just a few examples of how Kaleidoscope not only gives the user more visualization options than a standard plotting library, but also how it performs calculations for the user in order to allow them to plot such data. Now that we've shown you a wide range of the capabilities of Kaleidoscope, I'm going to hand it back over to Jeremy to conclude our video.
In conclusion, we were able to solve the initial problem by removing the user's need to sort through an HDF5 file and enable them to visualize the contained data. This project allowed our team to learn how to use several technologies like React and Flask, which work together in creating a full application. We've learned through this design process to work effectively as a team and how to communicate well with our sponsor. We'd like to thank our sponsor liaison, Dr. Jishuan Wang, as well as our senior design advisor, Professor Dong Shin, whose continued guidance helped our team tremendously. Thank you both. We hope you enjoyed our presentation on Kaleidoscope. Thank you all very much for your time.